So in this video, I will be teaching you about uh, how to how to solve ordinary differential equation, especially the first order ordinary differential equation. Okay, first order. Okay, so this first order you can break it into two. One of it is homo, and another one is non-homo. So what is homo non-homo? Review. Homo is no constant. Constant means you don't have any unknown, only number only. So when you have constant. Okay, alright. Now you can break it further into two, which is linear and non-linear. This one also you can break it into two, linear and non-linear. Each of these have its own method of solving it. Okay, now how to solve it? Let me put this. Okay, so now the method of solving. Alright, for non-homo linear, let me put this as method 1. Okay, this method is very important. For non-homo non-linear, you won't be learning it. Okay, alright. Okay, now let's look at this. Homo linear. For homo linear, there we call this as method 2. Okay, and then for homo non-linear, we call it as Bernoulli method. Alright, and then here got 1, 2, 3. Actually, you have a fourth method of solving first ODE. For whether it's linear or non-linear, if you can use this method. So I label here because it consists of both of these. So we call it as separation of variable method. Separations of variable method. This is the most easiest method. Okay, if you can separate it, you can use this method. If you cannot separate it, you have to know whether it's linear or non-linear and then do that method. Okay, let's go to the second part. So now I'm going to teach you all about separable separation of variable method. So in this method, what you have to know? There are a few things that you need to know. Okay, the first thing you have to know is you have to always express it in this way: dy dx equals to fx gy. Okay, from here you can see that this is a product of two functions, function x and function y. Okay, it's a product. Okay, let's try to review type of this ODE. Okay, so there is a dy dx. You cannot find any y2 or y3. You cannot find. You can only find y1. So derivative by 1. Okay, so this is first order. So this whole equation must be first order. The second one you can see is that you cannot find any constant. Okay, this one is function of x, this one is function of y. Right, you cannot see any constant here, constant or whatever. Alright, so there is no constant. So we call it as homo. Okay, the next one is dy dx, there is no constant, and the last one would be, please note this function y, the linearity. Let's look at linearity. This function y can be linear or non-linear. If you have y square, this whole equation will be non-linear. If you have only y, whole equation will be linear. So linear or non-linear? Okay, just like what I taught you before. Linear or non-linear, homo, no constant. Homo, linear or non-linear, this whole thing is first order. Okay, we are discussing about first order, of course lah. Okay, next thing before I do a question, you have to know a few things about separating. Okay, x square y over 2y square. Then this question, x square plus xy over x square plus xy, y square plus xy. So try to separate this. Whenever you see multiplication between x and y, or division and multiplication, you can easily separate it in terms of x square and then y over 2y square. See, you can easily separate to x function and y function. Now here there is a plus sign between one x and one y. X plus y. Whenever you see x plus y, you have to think carefully. Maybe you cannot separate it. Maybe you can separate it sometimes, but usually 90% of it you cannot separate it. Okay, so in here you really cannot separate it. Even if you separate it, it will look like this: x square plus xy over x, and you will get x plus y, which is, there is a plus here, so you have only partially separated it. You didn't separate fully. Okay, so this plus, if you look carefully, you can factorize the x out. Factorize the x out, you'll get like this, and then you get like this. Now when you remove the x plus y, you have already removed the addition symbol. When you remove the addition symbol, you can easily separate it to x function and y function. Okay, now let's try a question.